Hi there, just going to put some of our common questions from this last section that you guys posted on Schoology. I'll put those on line here. All right, should be ready to roll now. First one here, number 27. We've got two planes flying out of an airport. One is going to the east, one's going to the west. The one that's going east is actually going slower than the one that's going west. So the one that's going west is going to go further along. We do know that the total distance that they travel is 2,700 miles. So in a perfect world, what we'd like to know is what's the distance of my east flying plane and what's the distance of my west flying plane, which I have in red, and put those together should be 2,700. So basically, west plus east should equal 2,700. Well, how do you find the distance that a plane travels, or for anything travels for that matter? Well, what you need is to understand that distance equals rate times time. If you use unit analysis, which you'll be using in science a lot, freshmen, and hopefully some of you kids that have been around the block here, for students who have been around the block for a little bit have already used, is like unit analysis is when you take the units, rate would be miles per hour, time would be hours, and then treat them like fractions and cancel things that you can cancel. So here, if I multiply these two things, I can just cancel out the hours, and it leaves me with miles, and that's the distance. So distance is rate times time. Now, each of these is going to have a rate times time. I know the time of each. The time that the one going west is in the air is 3 hours. The time the one that's going east is in the air is also 3 hours. What I don't know is their rates. And when I don't know something, I want to use a variable, because this is algebra, we use variables to solve problems. So what I would do is probably say that x stands for the east plane's rate. I could have let it be the west plane's rate, that would have been fine, but I just know that it's going to work out better here. So I'm going to say that x times 3, or commonly known as 3x, is the distance that my east plane flies. Now, if the east plane's rate is x, that would imply that the west plane's rate, which they say is twice as fast, is 2x. So I just put a 2x here. So 2x times 3 is the distance that the west one flies. And 2x times 3 would be 6x. Now I have their distances as algebraic expressions. West is 6x. East is 3x. What do we have together there? They total up to 2,700. You get 9x is 2,700. Divide over the 9. That gets you x is 300. So the rate of the east plane is 300, and then 2 times that would be the rate of the west plane, that's 600. Plug in a 3 just to make sure that works. 3 times 600 is 1,800 down here. Up here, 3 times 300 is 900. If you add those up, you get the 2,700 we're looking for. Okay, next one. Length of a rectangle is 3 greater than its width. Perimeter is 24. So I have a rectangle. It has a length and a width. I don't know if they are, so I'm going to let one of them be x. Now it says the length is 3 greater than the width. Since we're using the width to describe the length, I would let the width be my variable, my x, or you can even just use w if you want it. Then we're going to write an expression that tells me what the length is. It says the length is 3 greater than its width. Greater than implies you're adding. So that would be 3 plus x, or x plus 3. So this is really what my rectangle looks like. Then it tells me the perimeter is 24. I know perimeters just add up all the sides. So I just need to add up all these sides. And set it equal to 24. Solve for x. And I'm ready to roll. So if I add like terms here, I get 4x plus 6. Subtract over the 6, I get 4x equals 18. So x is 18 over 4. 18 over 4 is 9 over 2, which is 4.5. And x stood for my width, so that's 4.5. Length is 3 more than that. That's 7.5. That'd be my dimensions. Okay, 51. This one looks real tricky because there isn't a single number in the mix, but what you got to realize is we're just solving for R2. So you could pretend that you know every other single term. Like I could pretend that capital R is 2 and R sub 1 is 3, just to help me think right. So if that was the case, it would look like this: 2 parentheses or times the quantity, 3 plus R sub 2 equals 3 R sub 2. Now, if I told you to do the problem on the right, I would guess you guys would say to distribute. Well, that's what we should do up here. They're the same problem on the left and the right. It's just I put some numbers in on the right. So we're going to have the same steps. So let's go ahead and distribute. So it'd be capital R sub 1, plus capital R sub 2, equals R sub 1, R sub 2. Over on the right, hopefully I'm thinking I'm going to get these two things on the same side, because that's like 2x and 3x. They're like terms. So on here on the right, I would subtract 2R2. That's what I would do. Don't confuse this little underline I did with division. Subtracting. 3R2 minus 2R2 is just plain old R2. So on the right, I would have got R2 already. R2 is 6. On the left, I want to go, okay, so on the right, I got R2s on the same side. On the left, I got to do the same thing. So I'm going to get the R2s on the same side by subtracting, same work. R1, R2 minus capital R, R2. And this is what I went over last week. We've got them on the same side, so let's factor them out. So we can write them as 1. Notice if I did this backwards, did the distributive property, I would end up getting this. That's what I want. So I factored that out. And now over on the right, I didn't have anything to do because 3 minus 2 is 1. You know, if I said R, let's say I would have used a 4 instead of a 3 for R1 right here, I would have got a 2 in front of here, 2R2. So then you would have divided by 2 at the end. Well, same deal here. You got to divide by the R1 minus R. And that'll leave that alone. Okay, so we had R2 times the quantity, just divide the whole quantity over. Another word problem, good review from last year. What are supplementary angles? They are angles that when you take, say you got angle 1 and angle 2, they add up to 180 degrees. Do you remember what adds up to 90 degrees, what they're called? Those are complementary. Okay, so I've got two angles here, A1, A sub 2. And it says one angle is being compared to the other, so just let one of these angles be x. And it says the one that's not x is 20 more than 3 times the original. So I guess I'm saying A2 is my original. Probably would have made more sense to say A1 is my original, but it doesn't matter. So one of them's x, the other one is 20 more than. More than is another way to say plus. And then 3 times whatever the other angle is. So we've got a nice algebraic expression for each one of my unknowns. I know that when I add those two things together, it's supposed to be 180. subtract 20, divide by 4, x is 40. So I know the original angle is 40, and I know the other angle is 20 plus 3 times 40, which better be 140 because remember, these two things have to add up to 180 anyways. And it is. 3 times 40 is 120, plus 20 is 140. Okay, I got a couple more, go through a couple left. 59, we're solving for x, so same type of deal that we did earlier here. We've got x on both sides, so I'm going to get those terms that have the x in them on the same side. So I'm going to minus that one over. I'm also going to bring the 4c over to the other side, and since it's a negative 4c or minus 4c, I'm going to add that over. Now you're thinking fractions here, I might have to find a common denominator, but actually they already have a common denominator, so I can go ahead and put these together. These are like terms. 3ax minus 1ax is 2ax with a denominator of 5. That's how you put fractions together with like denominators. You put the tops together, leave the denominator the same. Okay, we're solving for x. You could put 4c over 1, cross multiply. You could treat this whole thing as a fraction and say to get rid of a fraction, I multiply by the reciprocal. Fives cancel, 2a's cancel, leaves us with x. Put this over 1. 4c times 5 is 20c. 1 times 2a is 2a. Pretty good answer, not a great answer though, because it isn't simplified. 20 and 2 reduces to 10. So you should have 10c over a. And I thought I had one more. Let me pause here. And I'm back. I guess I didn't copy it down. Here was the last one I was thinking. Number 60, a minus c over x minus a equals m. This one, I'd treat that like a fraction equals a fraction. So I would cross multiply a minus c times 1 and x minus a times m. Distribute xm minus am. And then now on this one, we are solving for, we're solving for x again. Okay, well that makes it a lot nicer, solving for x, because there's only one x. We don't even have to group the x's. For some reason I was thinking there's two x's on this one, but oh well, bonus, there isn't. So, a minus c, I'm going to add over the am. That equals xm. So I just added that over, get rid of that, add, subtract. And then we've got x times m, so how do I get rid of m? Just divide. Got to divide the whole thing on the left. And that's what I saw for questions posted on 1.4. If you have any more, feel free to stop in or stay after or ask during any free time we have in class. Thanks for watching.